Hello and welcome to another video on DesignScript. In this video I'm going to introduce you to functions. So as you can see, we have some code that I've copied and pasted into the DesignScript editor window for brevity's sake. And you can see most of the code should be familiar to you by now if you've been following my previous videos. And so let me just step you through what's going on here. First few lines, create 2 points, and I use those 2 points to create a line. And then I extrude that line vertically to create a surface. I'm then using a function called pointAtParameter, which extracts the edges of this surface, and I'm connecting those edges together in an opposite pattern to create diagonals over the surface, as you can see. So the reason why I've made this script is because, let's say hypothetically, we wanted to take this same logic and apply it over a much larger surface, or a surface rather with many panels, perhaps a facade or a subdivision mesh with hundreds or thousands of individual panels. So one option would be to sort of take this logic we have here and copy and paste it hundreds or thousands of times, but that of course would be completely infeasible. So what I want to introduce you to now is the ability to create a function, which is a means of sort of wrapping the logic of a certain set of commands with a definitive set of inputs and outputs, allowing us to then take this same diagonal pattern and apply it to many surfaces at once. So I'm going to make a new file just to quickly introduce you to the idea of a function. So to create a function, you use the def keyword. Then you need a function name, say ret2, which will become apparent very quickly. And what ret2 is going to do is going to return 2. In other words, it's going to take the value 2 and kind of push it up out of the function. So to do that, and you should watch out because DesignScript uses a slightly different syntax than most other programming languages. You have the return and then an equal sign and then the number 2. What we can see then, if I say assign val the return of return 2 and then print it, we can see what the result is, and it's 2. Again, if I change this to 5, it'll update to 5. So there isn't very much logic inside ret2, but again, it kind of illustrates what the fundamental parts of a function are. The def keyword, a name, these parentheses signs, curly braces, and then a return equals with some value. Again, this can be anything, like a string. So alternatively, functions can also take parameters. Let's say I'm changing ret2 to mult2 for multiply by 2. And what it's going to do is essentially take the input and multiply it by 2. So here, the key thing to remember though is if we change this to mult2, and if we now have an input value to our function, we need to have an input value when we call the function. So we might input 5 here. So 5 essentially gets pushed into this function. If you can see my cursor, gets pushed into the function mult2, is multiplied by 2, and then that is returned out of the function. So we can run it, and we can see the value is 10. Again, if we do 100, it'll be 200. Functions can take actually multiple arguments as well, so we can say input 2. So maybe it's going to be input 1 times 2 times input 2. So now we might have 150, which is going to be 500 times 2, which we would expect this to be 1,000, and it is, or 10,000 rather. So that's kind of the very incredibly basic but not very useful function. Now we're going to try and apply that to our much larger script here. Okay, so looking at this code that we want to sort of abstract into a function, we notice that really the only input is this surface, and the output are the 2 diagonal lines. Okay, so let's kind of just cut and paste this out, Control X, and And we might say def make diagonal. We're going to have input surf. Okay. So I'm just going to indent these just to make this a bit more legible. All right. So now we have input surface. All right. So let's just kind of replace that with input surface. So right now we have corner 1, corner 2, corner, etc. So we have all our corners, and it's making a diagonal. So without kind of complicating things unnecessarily, I'm just going to return one of the diagonals. And you'll see why momentarily. Okay. So I'm returning one diagonal. We have our function make diagonal, and it takes an input surface. Okay. So let's just say diags, because there might be more in the future. Say make diagonal, surf. So surf is going to be passed into make diagonal. It'll then be sort of analyzed with this pointed parameter and stored into these corners, and the corners are going to be used to make diagonal lines, and those one of the diagonal lines will be returned. So let's see, if we run this, we can see, here we are. Whoop. Here we have our line that's being returned. Now, one thing to note here is that at the moment, it seems as though we can either only return diagonal 1 or diagonal 2, because we can't return, say, diagonal 1, comma, diag 2. I mean, that just doesn't work. The solution to that is to actually return a collection of values. And if you notice from my last video, you can create a collection using this curly braces. And so here, we're essentially taking these two diagonal lines created, putting them into a collection, and then returning that collection out of the function. So now, we have both our lines. Now, just to sort of, so right now, all we've done really is created a diagonal on a single surface, which isn't very, it doesn't sort of call the function multiple times. So what I'm going to do now is replace this with a cuboid, by length, and this takes a coordinate system, and then several values for the width, length, and height. Now I'm going to call make diagonal on the faces of this cuboid. Faces.surface geometry. So in other words, cuboid has a set of faces, and those faces have surface geometries on them. And I'm going to call then this make diagonal for each one of those faces. So again, as we can see here, now we have the same logic that we don't have to repeat multiple times in our code, being operated on many different types of surfaces. Some of them thin, some of them, square. And this then could be applied to hundreds or thousands of surfaces in any type of model. So that's what functions are and why you'd want to use them. Thank you for watching.